Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
Today we are speaking with Jon Hirshtick. He is the former CEO and founder of Solidworks, and more recently the CEO and founder of Onshape, who are innovating in the CAD space. So Jon and his colleagues noticed traditional CAD applications had a few flaws, and since then they've built a whole new service from the ground up, solving a lot of these problems a lot of designers used to have. So in this show we're going to discuss the power of the cloud for work and sharing projects. Also how parametric modeling, which he calls Parametric Modeling 2.0, is becoming more powerful. And also how BIM will change the industry. I learnt a lot speaking to Jon. He is a man with a lot of experience in the CAD space. I hope you guys enjoy this interview as much as I did, and without any further ado, here is Jon Hirshtick.
I was born in Chicago, United States, 1962. I came to Boston to go to college at MIT. I had started programming computers in the 1970s, and then I majored in mechanical engineering, and in 1981, I started as an intern working on CAD software. And I've worked in CAD ever since. I was manager of the MIT CAD lab, and most notably, I was founder and longtime CEO of Solidworks, which became part of Dassault System. I stayed there 18 years, and I left Solidworks to start Onshape, and then started Onshape about a year after I left Solidworks, and I'm currently the co-founder and CEO here at Onshape.
Awesome. So what do you guys do at Onshape?
Onshape is making a new generation computer-aided design system. We rethought CAD. We saw the problems modern teams have with old generation CAD, and we saw an opportunity to solve those problems if we rethought CAD and rebuilt it using cloud, web, and mobile technology, and that's exactly what we've done.
So how have you seen modeling evolve over the years since you started with, I guess, Solidworks?
So since Solidworks, well, the answer is until Onshape, it hadn't really evolved much. I mean, CAD, when we started Solidworks in 1993, we had a vision for, CAD, and it was on a Windows PC, which at the time was revolutionary, believe it or not. You can't do that on a PC. And you need a mainframe or a Unix workstation or something. Well, now those are all gone, and everyone's on a PC. But in file-based, and sell it for about a $5,000 license fee, and you'd install it and set it up in a PDM system. That's what we pitched in the 90s. That's what we innovated with in the 90s with SolidWorks, and that's pretty much, you say, what's changed? Not a lot. I mean, it's become more widely used, but it hadn't really gone through a generational change, and that's what led us to creating Onshape.
So what were some of the issues that you found professionals encountered the most just using AutoCAD, and what sparked you guys to start Onshape?
So, by the way, and I don't know what you're going to include in the podcast or not, so I'll make comments, and I assume you'll edit them. Is that okay to say that?
Yeah, of course. Definitely.
Okay. Easy. All right. So I saw you mentioned AutoCAD in there. AutoCAD, is not really used as the primary design system in manufacturing these days.
Okay. Yep.
I know in architecture it is, but it's really about SolidWorks and others. So I'm really talking about the problems with SolidWorks, or I could say Autodesk products, if you like. They have like inventors. So I'll take it like that way instead of commenting specifically on AutoCAD. So the problems that I saw customers having with old file-based products like SolidWorks, very popular, Autodesk Inventor, things like that, were really creating a gridlock problem, if you will, in design teams. And that stemmed from a few different factors. One, the software was hard to deploy to a modern team. You have to download, install service packs, license codes, license fees. And then the big problem is getting everyone on the same version. Every CAD user has this awful story about trying to work with someone else in their own company or a supplier or a customer, and they're on the same software but on different version levels, and you can never get the whole team on the right level. So first gridlock problem is deploying the software. Second one is managing data, whether you just want to collaborate with someone to work together, or whether you want to do formal revision control, or just keep track of your own work, really, the data management is a nightmare. Everyone needs copies of all the files, and these are typically thousands of files in a manufactured product. You get copies everywhere. You don't know who has the latest version. People try to put in PDM systems, but that kind of locking and checkout workflow creates gridlock. People are waiting on each other all the time. They're uncertain about what to do. Third area is the parametric tools themselves. Parametric modeling, which is the way most manufactured products work, and that works really well for a single part, but as you try to get into more powerful things like complex configurations, design and context, custom features, sheet metal, things like that, you would find that the parametrics model didn't work so well. It was kind of kludgy, and you kind of stayed away from that. A lot of companies banned the use of things like in-context design because it didn't work so well. So those are the three sort of gridlock areas we saw that were costing teams time and restricting. A lot of times they're not innovating as well.
Yep, definitely. I've felt pain from all three of those things as a structural engineer in the past. So the first one you mentioned there was it's hard to deploy, and from my understanding, you guys have somewhat solved this problem by putting all the software on the cloud. Is that right?
Correct. We're the only professional CAD system where the CAD system and the data live in a single secure cloud workspace, and they're never copied anywhere. Yeah. So you don't install anything. If you have a web browser, Linux, Mac, Chromebook, PC, iPad, you don't even need the browser on the iPad or iPhone, Android, whatever. You use us pretty much instantly on anything. Yep. And everyone's on the same version. And it's impossible for two users to be on different versions.
Yeah, okay.
And you started to say, and you can
access. Oh, so you can access it anywhere as well. Is that right?
Yep, anywhere. Yeah, anywhere. You access it anywhere. The system and the data.
Yeah. So the model will evolve to the latest version as well. So there's no miscommunication with different versions of software.
Correct. There's or different versions of data.
That's awesome. And the third one you mentioned about the actual capabilities of the modeling. I read an article on Parametric Modeling 2.0 written by yourself, I think. Can you just elaborate on what parametric modeling is before we go into how this might be more powerful?
Sure. By parametric modeling, I mean the use of features and parametric control and ordering. I mean a way of creating a 3D model as a sequence of modeling features in a ordered list that is regeneratable when you make a change. That's what I call sometimes called parametric feature-based modeling, or sometimes just feature-based modeling.
Awesome. And what does the new version of parametric modeling, how is this different to what it was in the past?
So in the past, we looked at parametric modeling was really good for modeling a single part with the ordered list of features. That worked really well. But the problem was that the problem was that when people there were things at the edges of parametrics that people wanted to use that didn't work very well. So an example of that is design in context, where you're designing a part in the context of an assembly. So you see a whole bunch of parts of a machine, let's say on the screen. You want to design one new part in the middle, and you want to reference those parts in the assembly. It's a great idea. Unfortunately, in old parametrics, it didn't work very well. You get a lot of uncontrolled updates and problems. And that's one area. Another area is custom features, where people, almost every user looks at the feature set. Like the CAD system comes with features like extrude, fillet, shell, and so forth. Those are very familiar to users of these systems. But most every user wants features that work a little differently, or maybe new features that added into the system. And other systems have basic ways to do that, but it doesn't work very well. And with Onshape, they're all custom features. We have a language for writing features called FeatureScript. Our own features that we offer are written in FeatureScript, and you can write features. You, literally, Adam, you could write a feature in Onshape, and if you showed it to a user, they couldn't distinguish it from the ones that come with the system. It would be just as fast, just as beautiful in the user interface, just as well integrated. And that's another area. Another thing is multi-part design. As I said, the feature list worked great for one part. And in old CAD, what people typically do is create one part per file and try and put the files together. A much more powerful idea is to create a whole set of interrelated parts in one file, one feature list, if you will. Now, that sort of works in old CAD, but there are problems. I won't get into all the details. There's a lot of problems with it. In Onshape, we made the multi-part design process work really well with something we call multi-part part studios. And finally, one more thing I can throw in is configurations. A lot of parametric users, in that case, you're leveraging the power of the list of features by creating a table with options, parametric options for your model. Say you have a small one, a medium one, and a large one, and those are the rows, and then across the top you list different dimensions like height, length, and width, and you switch between them. Well, in a simple example like that, it works great. But if you want to make a complex configuration with, say you had not only those 3 dimensions, but 5 other options that were specified, is the mounting plate on top or bottom? Does it have 5 holes or 6? Does it have a side exit exhaust port or a bottom exit port? If you add all those things in old CAD, the tables would explode exponentially, and you'd have some big spreadsheet with 10,000 options, and users' eyes would glaze over. We'd redesign configurations so that you can make those complex configurations with very, very small tables. We took a different approach to it. And so these are, I could go on, but basically we just we built on the same beautiful core of parametrics that worked really well, and we extended it to do a great job on these more powerful tasks that modern designers want to use. That makes sense.
Oh, definitely.
So we kind of been,
So you can eliminate some of the unnecessary stuff and just to make everything more simple.
Yeah, exactly.
And again, that probably works very well on being on the cloud, because whatever updates someone might write in, they can access it straight away rather than wait until you get the new version. And this seems to be happening in a lot of other areas. Like if you look at Tesla's cars, they have followed the same model where they have updates rather than wait for the new version. So it seems like you're the first one in the modeling area to I guess move into the update on the cloud.
Yes, yeah, exactly. I mean, that's exactly right. We're the first one where everyone in the world is upgraded at the same moment.
Awesome. And you've got another special feature. I saw the sharing feature. Can you elaborate on this?
Sure. Sharing is a way to communicate with your colleagues that does not require you to copy files. We're the only system in the world still that lets 2 people work without making a copy of files. So when you hit the share button in Onshape, you're inviting someone to edit your database, or just view. You can invite them to view when you share. And the point is, you're inviting them in to look or edit at a live master database, not telling them to make a copy. Every other CAD system out there, all the old CAD systems, ship copies of files around, and that's how you work with your colleagues. With the share feature in Onshape, you invite them into a simultaneous viewing or editing session. And so we think it's a much better way for design teams to work. It's very similar to what's done in Google Docs. If you've used the Google Docs, the G Suite, Google Sheets, Google's word processor, Google Slides, those apps work the same way. You hit the share button.
And I guess you can probably send this to clients as well, and they can see whatever you're working on update as it goes throughout the project.
Exactly. So what, and that's important. You absolutely share your client in, and they can see in real time. And so it really is all about letting people work faster and do the best work they can. And quite simply, if your client can look at your work in real time, you're working faster. Not to mention eliminating the confusion of, oh no, I wanted you to look at the file, not the one I sent that said final, but the one I sent that said really final, and that kind of stuff. We've all been there as engineers, and that wastes time. It creates confusion. You're hesitant to make changes because you're worried, well, I'd have to send out another copy or something. All that goes away. So, people love it for sure. And we have a lot of design firms in the structures and construction business in particular. You're dealing with people who are in tight time frames. Yep. And you have a very large set of people that you want to see that data and involve. And
and you've mentioned this a few times on the podcast, but one of the biggest nightmares for all designers is when you've been working on something for hours and hours, and then it crashes, and you've wasted a full day of work. So how does Onshape? How is Onshape different in stopping this nightmare?
So Onshape has virtually eliminated crashes. And it's completely different because in Onshape, again, it gets back to the beginning, how we're built differently. Because your data is in a database, in a secure cloud workspace, and it's not in files that get copied everywhere, what it means is your work is continuously saved. So in old CAD, your work is never saved until you save a file. And at the moment you save the file, you've saved what you're working on, if it's successful. Sometimes it's not. But you've overwritten the thing you had an hour ago or a day ago that you might want to keep. In Onshape, every time you make an edit, it's a transaction in a database. So if you change the size of a hole or you add a part to an assembly, that's immediately recorded as a transaction in the database. And there is no file to ever save, and you can go back to any state you ever had.
Oh, wow.
You can go back. You can say, well, wait a minute, I messed up here. You don't have to do any version control or anything. We have version control also, which is a powerful thing. But even if you never use version control, like in the example I just gave you, I said, change the size of a hole and then put a new part in the assembly. And you're like, oh, wait a minute, I didn't mean to do that. I messed up my model. You can go back in our version graph and you can look back and say, I want to revert to the state before the hole went in, and boom, you're right back there.
Yep.
It's as if you never left.
Yep.
We also just the very nature of our architecture means the whole experience of a crash is virtually unknown to users.
Awesome. Yeah, that's unreal. Yeah. And how can Onshape interact with other new technologies that are on the horizon, say AI, VR, or say BIM? How does it go with these new technologies coming through?
Absolutely. So yeah, Onshape can work with, for the future, I think you'll see us working with things like AR, VR, mixed reality. We have a partnership with Magic Leap that we've announced. We have not announced any details of that. We just said that we have a partnership, and they've said the same thing. But if you think about it, in the world of AR and VR, it's an even more important thing to have a true full cloud architecture like we have. Because in a file-based architecture, you'd be trying to copy files onto a VR device. I don't even know how that would work.
That's right.
In Onshape, we could, in theory, like we already have full CAD clients for mobile phones and tablets. So you could imagine in the future, if you showed me a new device that was a standalone mixed reality device or, augmented reality device, we could use that as a client because we don't have to move our CAD system to the device. Our CAD system lives in the cloud, and the device provides an end-user experience. Also, VR and AR scream for collaboration and sharing in real time, as opposed to file copies, which is perfect for us. Yeah. And then you mentioned BIM. Yeah, absolutely. We have an API, and we could link to BIM systems, and we increasingly have customers who bring Onshape models into a building model. That we don't make the whole building, but if you've made a wall structure in like I have a customer who's working on some residential housing and has designed a new type of wall structure, and they model that in Onshape, and then they bring it into a larger model of a home or building.
Unreal. So, and as a final question, as we begin to wrap it up now, and this answer doesn't have to be in your field at all, but what do you think will have the biggest impact on the buildings industry?
Wow, what will have the biggest impact on the buildings industry? Ooh, that wasn't in the outline. Well, it was in the outline. You're right, it was. But I like that one. Yeah. I should have thought more about that. What will have the biggest impact? I think, well, I'll give you a couple of things I think might have the biggest impacts on the building industry. One is more and more sections of the building will be designed as manufactured products. Increasingly, the building is going to become, manufactured in pieces using processes more common to how consumer goods or automobiles or aircraft are manufactured. I'm not going to say it's going to be completely that way. I'm just saying it's always been partially that way.
And
like if you look at today's buildings, the electric outlets, the light fixtures, the furnishings, those were designed in manufacturing-based CAD. And what we're going to see is, I think we'll see more of the structures. We'll see more subsets of the building designed as a manufactured item and built that way in a factory.
Is that to aid in speeding construction, you think?
Yes, in speeding construction and in creating more accurate results and speeding design. Because, the ability of a system like Onshape to design, say, for example, a set of walls or a structural assembly is much faster than you'll find it using something like a 2D CAD system or even a building system. So there's more and more pieces of the building that people will get done faster and more accurately with manufacturing CAD. And I think even my competitors agree on that. I think if you talk to Dassault System or Autodesk, they'll tell you the same thing. The other thing that I think is going to happen is that you're going to see more and more use of what I'll call data management technology in building the building. I was on the board of a company called Bella Systems, and they're going to be collecting more and more data in the field. That construction workers will all have mobile devices or eventually AR, VR. And they may not be involved in design, but the dissemination of the information and tracking the construction are going to be big. So essentially, the IT connectedness of the entire building construction workforce is a big deal. I think.
Unreal.
It's not my field today, but I think it's a big area. And we see companies. There's some great companies to look at. Like I don't know if you've heard of Assemble Systems.
No, I haven't.
They're a good company to look at in construction. You might want to get them on the podcast. Jon Hirshtick, their CEO, Assemble Systems. Another one is SmartVid. If you know smartvid.io,
no, I haven't.
Look them up.
Yeah, definitely.
Really clever construction application. They use AI to look at video on the construction site. I know it sounds like completely space age. Really great company. So very exciting technologies there. And our world is playing a part, the world of Onshape.
Yeah, fantastic. Yeah, the future sounds exciting. And if people want to find out more about yourself or Onshape, where should they go?
Onshape.com. You can find out more about Onshape at onshape.com. If you like, you can you can create an account. You can if you want to reach me, I'm on Twitter at J Hirshtick. That's a good way to reach me for people out there. And it's easy to learn a lot about Onshape online. And we have a great team of people here if you have questions to talk to us as well.
Phenomenal. Well, thank you so much, Jon. I'll end the recording there, but that was amazing. Oh,
my pleasure.
Yeah.
And thank you. I really appreciate your interest in us.
It sounds like you guys are doing amazing work, and I look forward to when it gets taken up by a large majority. So, how long are you guys? When did Onshape start?
We started about five years ago, but that was in a conference room with nothing.
Yeah.
So just about 5 years ago. So we're pretty happy with our progress.
Yeah, awesome. Look forward to it getting taken up by the early majority, late majority. So
yeah, we are doing, we're still a small part of the market, but we have thousands of commercial customers. We have tens of thousands of students and teachers, and we have quite a few users. You're in Australia, is that right?
Yep.
Yeah, we have quite a few users in Australia. We have a case study on our website from a user in Australia. I'm going to check and make sure that's the case before I actually tell you that. Always got to be careful with our customers. Most of our customers are people we cannot mention, but that
won't go live anyway. So
there's a collaboration. If you look, there's a case study on Walkabout Mother Bins. It's a collaboration between a U.S. company and the Mother Bin. Walkabout Mother Bins.
Yep.
And he's collaborating with someone in Australia.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future.